Okay, let's go ahead and talk about the next topic, which is amortizing notes or installment debt. Basically, these are obligations which are paid off over time, where each payment includes both principal and interest. Personal examples would be your mortgage note or your car note or your credit card bill, anything of that nature where you're carrying a balance, and as you make periodic payments, those payments include both interest and principal. Now again, there are many scenarios where interest-bearing debt is paid off in installments. And when these payments are made, the payments are allocated between interest and principal. For example, let's assume we're going to buy some land for $100,000 on January 1st, 2001, and the seller is going to hold a mortgage charging 10% interest, which let's assume that's a fair market rate of interest, so there won't be any discount or premium. And you're going to pay off that $100,000 in 3 equal annual payments, each December 31st from 2001 through 2003. And the first thing we have to do is figure out what's going to be the amount of the annual payment. Now, if there was no interest, then we'd simply take the $100,000 and divide it by 3 and get $33,333 per year. Instead, the loan is going to accrue interest at 10% on the remaining balance at any point in time, which is going to be paid off as part of the annual installments. So here's a picture of the cash flows. $100,000 today, to be paid off in 3 equal annual unknown payments over the next 3 years. We have something worth $100,000 today, and we want to know what equal annual payments over 3 years at 10% will equate to that. Now the first question is this a present value problem or a future value problem? And this gives people more trouble than you would think. Again, here's a picture of our cash flows. This is a present value problem. Now again, the reason people get confused is they say, well, the unknown amounts are the future amounts, so this must be a future value problem. That's not the issue at all. The distinction between a present value problem and a future value problem for an annuity is not based on which ones are known versus which ones are unknown. Basically, the present value of an annuity takes a series of equal payments equally spaced in time, as represented by the question marks up above, and converts them to a lump sum as of some date before the payments. So sort of generically, if you let the x's represent the small equal annual payments, and the big question mark represents the lump sum, it doesn't matter which one is known versus which one is unknown. It's simply a matter of taking the equal annual payments and converting them to a lump sum evaluated as of some date before the payments start occurring. The future value of an annuity takes a series of equal payments equally spaced in time and converts them to a lump sum as of some date after the payments. So again, in this case, we would take those 3 equal annual payments and equate them to some lump sum, equivalent amount as of some date after the payments. Again, that's the only distinction between a present value of an annuity and a future value of an annuity. It's not which is known or which is unknown. It's a question of, do you want the equivalent lump sum evaluated before the payments, or do you want the equivalent lump sum evaluated after the payments? In accounting, we tend to use present values a lot and almost never use future values. The case where a future value might apply, for example, again, that last little diagram, would be if you were going to put, $3,000 per year into your retirement fund, how much would you have when you retired at the end of that time span? That would be an example of a future value of an annuity. What will that stream of payments grow to when all is said and done? So in this case, we're looking at the present value of an ordinary annuity problem, n equals 3 payments, I equals 10%. Again, the present value, which is known, equals the amount of the payment times the interest factor. The present value is $100,000, the payment is what we're solving for, and the interest factor for a 3-payment 10% ordinary annuity is 2.48685199, etc., etc. So the annual payment is going to be $40,211.48. So we're going to make 3 equal annual payments of $40,211. That's going to add up to $120,634.44. And again, that represents the $100,000 purchase price plus the interest that accrues as the note is getting paid off. So let's go ahead and record the purchase. That'll be straightforward. We record the acquisition of the land, and we record a promissory note payable. Now at the end of 2001, we're going to make our first annual payment. Just as is the case with your mortgage or your car note or your credit card bill, when you make a payment, they first say, okay, some portion of this is interest, Whatever's left over pays down the loan balance. So when we make that first payment of again, remember that our loan balance is $100,000 at this point. When we make that first payment of $40,211.48, we write a check, and we say, okay, of that, $10,000 represents interest expense. Again, 10% of the $100,000 note balance. That leaves us with $30,211.48 left to pay down the note. So after this first payment, the balance on our note has dropped from $100,000 down to $69,788.52. I would strongly suggest, it would be in your interest to go ahead and take a scrap of paper now and make a little T account to show how this note is getting paid off in sequence. Again, notes payable starts with a $100,000 credit balance. We just paid off $30,000 of it, so the note payable balance is now down to $69,788.52. When we make our second payment, we're going to do the same thing. First, we write our check for $40,211, and then we say to ourselves, some portion of that is interest expense. Interest expense will be 10% of our note balance, and again, our note balance is now down to $69,788.52, so our interest expense, $6,978.85, 10% of the note balance. Whatever's left of that $40,000 payment goes to pay down the note payable itself. So we've paid off some more of the note balance. After two payments, the balance on our note is now down to $36,555.89. Again, I'd strongly suggest using a T account to keep track of this as we go through. We're now ready to make our third and final payment. Again, we write a check for $40,211.48. Interest expense will be 10% of our loan balance. So 10% of $36,555.89 is $3,655.59, which leaves us with $36,555.89 to pay off the note. And again, we didn't have a rounding error here, so the note payable has been exactly paid off down to the penny.